Can everybody hear me? Check, 1, 2. Okay. So, good afternoon, everyone. My name is Shreyas, and I'm a course rep for CSCA08 this semester. And thank you all for coming for the final review seminar. I'm joined by my colleagues, Damien and Chris, who are going to be presenting some of the topics for the final exam. So let's jump into the agenda for today. For today's agenda, we're going to be going over function runtime and tracing, sorting, string slicing, files, memory models, testing, dictionary and tuples, and docstrings. Some of them are going to be just reviews, and some of them are going to be new topics that you learned after your midterm, so pay attention throughout the video. So,
we're just going to be getting started with runtime. I'm sure everyone's familiar with what runtime is. Not like a literal measurement of time, just tracing through the steps that your program executes. So this is kind of the way that as you get more experience, you kind of use it to measure how effective your algorithms are. And we typically do this by counting the amount of operations that a program executes. So operations kind of include things like comparisons, additions, and everything like that. Typically that depends on what your algorithms are. And you typically count them using the amount of iterations your loop executes. So if your loop executes 8 times and you perform one operation per iteration, you have a runtime of 8. For our inputs, typically at this point we're going to be using strings, lists, and numbers. More so lists and strings. And the size, that typically depends on the question. If you're iterating over a string, for example, your size would be the length of the string. So this is a question from last year's final. It says, give an example input list of length 5 and a value for the second argument, which returns in the most iteration of the loop that it contains. So just think about it for a second. Try and come up with 2 arguments that will result in the most iterations of this function.
1, 1, 1, 1, 2, and then for the answer 2.
Right. So to generalize it, yeah, you kind of want to make this to make it run the most times. You want the object that you're looking for to be the end of the list, because if you can see, right, you iterate through the list, and if you reach an element, then if you reach the goal element, then you're going to return true. But if that element's the last thing in the list, that's going to be how you result in the most amount of iterations. So for the example, we have 1, 2, 3, 4, 5, 6. As you can see here, this one includes the search item as something not in the list, but if you have something not in the list or the last item, you're iterating the same amount of times. So either one works. So we go through the list one at a time, right? We see the first element isn't 6. Go to the next element, it's a 2, also not a 6. And we keep going. Every time we iterate, we increase our counter, and then eventually we return false with 5 iterations. Perfect. So this one says, give an example input list of length 5 and a value for the second argument, which results in the least amount of iterations. So give you guys a second to think about something that'll process that.
So you can have a list that's literally empty, or you can have a list that has, like, say, maybe number 1 and then the item is.
Well, in this case, it said for length 5, but yeah, the idea is correct. Where basically you want for it to run the least amount of times. You just want the search item to be the first thing in your list, because then you hit it. The first if condition checks. Okay, this is the thing I was looking for. I'm done. Okay. So the example here is the list of numbers 1 through 5. The item you're looking for is 1. Enters the iteration. First thing I look at is 1. Okay, I'm done. Return true. Okay. First iteration. Okay, we made a check. So this is another function called save element, which uses the contains. Basically, what the function will do is compare if the elements of list 1 are identical to the elements of list 2, not necessarily in order, just do they contain the exact same elements. And in terms of measuring the runtime, we're just going to be using the comparisons in terms of because there really isn't much else going on. So the main thing that we're going to use to track our time is going to be the comparison. So, for this question, we're going to see, give a list 1 of line 5 and a list 2 of line 5 that will result in exactly 3 calls to contains. So, we don't need like anything specific, just like what do we need for that to be true? Sure.
So I think like, for example, the first 2 numbers are going to be like in the list of the, and then the third number will be basically, will be different, I believe.
Yeah, so basically what we want to look for is something that the first 2 elements do appear in the other list, or appear in both lists, but the third element, regardless if it's in list 1 or list 2, doesn't really matter. But we want that element to be unique, so it doesn't exist in the other list. Okay? So we have these examples here, right? We have list 1 through 5, and then 1 through 6, but replacing the 3 with the 4. So we see we hit 1 and 2, those return true, so that's 2 comparisons. We look at the third one, 3 isn't in the second list, okay, we return false. Okay? So keep going through, boom, we hit the third one, right away it terminates because it returns false. Perfect. So now this is generalizing a bit more, so we're not looking at a specific number of iterations, we just want it to cause the most amount of iterations. So we want to think of an idea that will give us 2 lists of length 5, where the iterations will be the largest. Sure.
Completely equal.
Yeah, that works. So 2 lists that are exactly the same. As you can see here, one thing that I wouldn't try to get confused, the order doesn't matter at all. Because you can see in our contains function, it doesn't check whether the positions are equal, just whether the list contains a number. Right? So you think about the most comparisons that contains can perform is 5. And this happens when the list doesn't contain the item at all, or it's the last element in the list. So that is pretty much it, right? So when we will perform 5, then 4, then 3, then 2, and then if it's not in there, we'll do 5. So when we talk about runtime, we typically generalize it. We don't care about a specific input. We want to see how the algorithm scales as we make the input larger. So we consider it a general size n. And we want to say we're given 2 lists of length n, then in the worst case, how many comparisons are performed. So you guys can think about it for a little bit, try and come up with an idea. Obviously, don't look at the number at the bottom, that's not too helpful. But. So, the worst case occurs, like we were saying, when the item would be the last element in the list. So when the first n-1 elements are in the last n-1 positions of the second list, so that requires the most amount of comparisons, because we're going to go through the first one, and it's going to be true, but it's always going to cause the most comparisons because it's going to be the end of the second list. So consider this is our 2 general lists, right, besides n. Right? We need one element to be uncommon for that to happen. And we can see that the first n elements are going to be in the last portion of the second list, so that's going to result in most comparisons because we actually have to iterate through the entirety of the second list. Yep.
So we're not considering like the contains for this two comparisons that will be based upon like that items in that list.
That's actually all we're considering. Because when the call in the if statement, you're not going to consider in terms of the amount of iterations. We're going to consider just the double equal sign as a comparison. That's what we're counting for. Okay. So we're going to have n comparisons for the first part of the algorithm, so the part that iterates through the 4. We're going to have n comparisons for that, so we sum from I from 1 to n. And then we have n comparisons for the second list, because we're iterating over the n-1 to 1. And then we have to subtract 1 because there isn't the one that's going to return false isn't going to be a comparison. So we expand these, you should be given, or should have been taught what the expansion for like the sum of a number is, or like the sum of its I is. So that's going to expand to n times n plus 1 over 2. And we just have to take care of the minus 1 and the plus n. So gathering these terms here, right, the n and the n from here, we end up with this final result of 1/2 n squared plus 3 over 2 minus 1. Is everyone clear about why we got these values, or is anyone a little confused on, like, or anyone has any questions about why we got these results? Sure.
What if n is off?
It doesn't matter. They're going to be both the same height, so it doesn't particularly matter.
Like here?
return just any n. So we don't really, it doesn't really matter what the actual result is. It's more of just, okay, if I have this many iterations, it's going to run this many times. Typically, you would floor the divisions, so you wouldn't like cut the decimal off and just leave it at that. Yeah. Does anyone still? Is there anything people are still saying unsure? Yeah. Why we have these counts? Yeah, sure. So when we go through this first list, right, we have to basically want the first set, the first like portion here. So x1 through x minus n, x sub n minus 1. We want those to be the last n minus 1 elements of the second list. So such that when we check with x1, right, we're going to compare x1. Is it in list 2? Okay, we have to go through every element in the list. We see that it's finally the last one, right? And then we go to x2. We look through list 2, we keep going, we have to go through n minus 1 checks. And we do that with every single one until we reach this value y that isn't xn. So we're going to have to, that's going to cause the most amount of iterations because we have to do the bulk. The iteration count's going to be the same, but that's going to cause the most checks because we have to go to the longest possible length with each iteration. And yeah. Yeah. Oh.
Yeah, so will we be given, let's just say we have like, for this exact same question in the final. Will we be given an explanation for what the contains built-in function does, or do we just have to know what it is?
Well, we'd be given the function implementations. I mean, if you're not, which you will be, but if you're not, assume, right? Try and assume like what would it be doing, but you won't be in a case where you won't know what a function is doing. You have to guess it. And in terms also like the sigma notation, last year when we wrote this, we didn't have like a sheet that gave us what it expanded to. But I mean, I would say in preparation, remember this one and then the I squared, because those are going to be typically the only ones you'll have. I can't say for sure, but I cubed, you're probably not going to have to analyze something that's going to be. Yep.
The I squared and the I.
I can write them down afterwards. I can't remember I squared off the top of my head. I think it's n squared times n plus 1 all over 6, but I can't remember. Perfect. So now here we're going to be looking at best case running times. So we want to find out an idea of two lists of the same length, or length 5, that are going to result in the best case running time, meaning the least amount of comparisons. So if you guys want to think about it for a second, just come up with an idea and we'll go through what it would be. Sure.
Is that both lists have different numbers? There's like both lists have different elements in the system?
Yeah, well, you can just say that as long as the first two elements are different, you're pretty much going to run into one iteration because it's going to immediately return false, and then if not false, that's going to be true, and then you're going to return false. So, in this case, right, we have that exact scenario where we have the same list, but the first element differs in the list. So the first check is going to be false in the contains function. And then when we check that if not contains, right, it's going to be given a false. It's going to be if not false, so it's going to become true. And then we return false. So this condition is going to be met when the elements are different, and then we're going to return false. The earliest same elements can return if the first element of list 1 is not in list 2. So this could be generalized to however many, whatever the length of the list is. And why would we not consider the earliest that contains can return every time? Sure.
Does you have to check if every element, not just one is an element of this, you're not going to go through every element?
Exactly. We're going to have to go through every element because it might be the last one, like we saw in the last example. Yes. And yeah, so this is just saying, right, okay, like we have to check, like your peer mentioned, if it's not the first one, that doesn't mean it doesn't contain. So we are going to have to iterate through the entire list, regardless of where it is, to be certain that it's not. Okay. So we're going to take this the same way we took the last case where we were looking at worst case. We want to generalize the best case thing. So if we're given two lists of length n, then in the best case, how many comparisons will we perform? How many do you guys think? Just like an idea. Sure. N? Is that like the general consensus? Okay. So the best case occurs when the first element of the list 1 is not in list 2. So this is going to be like the structure of the list. It doesn't even matter what the rest of the list is, it could all be the same elements. Like x2 through xn could be identical. As long as x1 and y aren't the same, we're going to reach our best case. So it's going to be in comparison since we do have to check. So this is a multiple choice question. I'm going to give you guys about a minute to think about what this is going to be. But it says if you look at this code on the left, how many iterations are we doing? So what is the range of our for? Oh, sure. Yeah.
Is it D?
Yep. So basically, when you want to think about this, you don't even have to, it's really not that complicated. You take the second value of your range first and subtract your first value of your range from it, and that's going to give you the amount of iterations. Right, so we do the length of the list minus I plus 1, like in parentheses, and you get len list minus I minus 1. You can come get it after. I'm not going to throw it up there. I won't be able to get it over there. Perfect. So this is a function that, so look at the function here and see what the output is going to be. So not the return result, but the what's going to be printed to the terminal. Sure.
It's going to be C, got that and return to 10.
Exactly. So we're going to, first, we don't look at the function code. Python's going to go straight to the print statement and then say return string at at 10, right? So we're going to pass 10 into our function. We can see here that the second return is kind of redundant. So this is kind of meant to trick you, right? Because this x equals x plus 1 never gets touched, regardless of the input. So we're going to say dot plus the string of 10, and then it's going to return x. So then the return value is going to be the string of x, which is just going to be 10. Perfect. Now, this is another multiple choice question that a lot of people can make mistakes on. So it's going to say, which order are the functions called in this expression? So f of g of h and I. Yep. HIGF? Why?
Because when you call when you call f, you have to make sure you have the value of g. So when you have g, you have the value of h. But when h is just called, when the parameter of h is x, which is not a function, then you can have the return value sending. And for I, the same in this case. So it's I, h. That's idea.
Yeah, exactly. One thing not to get confused with is b, because that's a pretty common answer as well. You kind of think about it as bedmass, right? Once we get to the innermost layering of our function calls, we're going to perform the operations from left to right, the same way you would when you're doing bedmass and you're adding, right? When you're adding two numbers, you add the left one and the second one because it's the same function. Yeah.
So essentially, you just have to check what the outermost functions run on, and so on and so forth. You put it into the very most center, and if there are two functions that are being put in your center, like in this case, you use the bedmass.
Yeah, pretty more or less. That's a good way to think about it. So you guys have covered, I think, a couple sorting algorithms in your class. Definitely selection and insertion sort. We're going to be going over insertion sort here. I think bubble sort should be another one that you guys go over. I would say we're not going to be going over that here, but it's very similar to the way insertion sort works. So the main idea of insertion sort is for each element of the list, compare it to the element to the left, and basically you want to sort it from left to right. So you keep going until it's in unsorted order, and then you sort the left subset of your list, and then you just keep going and then keep doing it that way. So for this list, right, we check 5. There's nothing to the left of 5, so we have nothing to sort. Now we go to 8. Well, is 8 bigger than 5? It is. So we're still sorting. And then we look at 10. We're still sorting. Now when we look at 2 and we look to the left, right, we can see, okay, 2 is smaller than 10, swap it, right? And now we compare it again to the element to its left. Compared to 8, it's smaller, so we swap it. Same thing with 5, and so on. And then once we hit 4, we're going to be doing the same thing. We just keep swapping it because it keeps failing with comparison checks. And then once we hit 2, we're like, okay, 4 is bigger than 2, we're going to leave it here, that means it's sorted. And this kind of approach it follows through the rest of the sorting process. When you compare a number to itself, it isn't less than, so you don't want to swap them. And that's pretty much it. It's very naive approach to sorting. That's pretty much it. That's all. Anyone have any questions about how the insertion sort works, or anything that's a bit, I would say, unclear about why it does what it does? Oh, we're all good? Okay, great. Chris? Oh, yeah. Yeah.
These slides will be given to us later on.
I believe so, yes. They'll all be posted for the, and all that stuff. Yeah.
So this is going to be one of the, well, this is an example of something related to sorting that you might have to do on your final. This was on the 2022's, last year's final exam. This is question 2. You read the function, you'll do another one later, but this one, you can read the doctrine. You want to insert into tuples at the appropriate position so that tuples remains sorted by the elements at the index of sort by. So you'll have, you'll be given a tuple and then a list of tuples, and then at the index given by sort by, you want to, this is what you want to use as like sort of your key that you want to be sorting the entire list of tuples by. So give this another, yeah, so you give this another read, and then on the 2 fill in the blank lines, one on the while loop, and then one as the parameters for the insert. You're going to try and figure out what is the blanks that you're going to want to put in there. And at any point, anyone have any suggestions for the answer to the question? Raise your hand and we'll.
While I is less than the length of tuples and tuples at position I plus 1 at position sort by is greater than
Yes.
sort by.
Sorry, yeah, something that wasn't specified in the question, yeah, I also forgot to mention. The order in which you want to sort it is just increasing order, so not decreasing. Yeah. So that is correct. Except for the index that you want to check for is just, don't have to do I plus 1, you can just check for the I. Oh, sorry. Hold on. No, the I at the I, no, you're right. Any ideas for the second one? Or anyone else? You raising your hand? Yeah, yeah. Oh, or no, the.
Would you do tuples that insert at this point?
It is, so essentially the first one, the first section of the code where you're just trying to figure out like what I is going to be the position that you want it to be. So you will insert it at the I position. And then, do you remember how many parameters the insert takes?
Oh yeah, so it's the position of the item.
Exactly. So 2 chocolates. You get 1. Oh, sorry. Okay, really throw. And then you get 1, right? Oh my. Okay, so yeah, this is the next slide is just a concrete of what both of you guys had just said. Okay, so basically, basically what we're trying to do in the first while loop is we're trying to figure out the position that we want to insert the tuple at, and then after we got the position I, then we want to actually insert that into the list of tuples. And you remember that insert takes in 2 parameters. It's the position that you want the element to be in, and then the actual element. So then, what we're doing in insert is we're going to put tuples at position I, and then all of the other elements will be shifted to the right by 1, which is exactly what we want there. Any questions about this slide? And then, oh yeah, part 2 of this is that now we have our myInsert function. We want to make another function that actually sorts a list of tuples based on an index at given. Sorts a list of tuples based on the element at the sort by index. So try and come up with what you guys would like these blanks to be, and then I'll give you guys a minute or 2 on that. And then if you have any answers, go ahead and raise your hand.
So sort suppose is just an empty list,
Mhm.
and then my underscore insert two oh wait what?
I can go to the
Oh,
previous
no.
slide if you like to.
Oh yeah.
Yeah, so that's what it looks like back.
Okay, so it's two and then sorted to all
Yep,
and sort by.
exactly. So, so exactly, yeah, that's exactly correct. We initialized initially the sorted tuples as just an empty list. And then the idea behind this is that for each item, for each tuple inside the list of tuples that we're given, we look at this tuple and then we call the myInsert function, which we will pass in the initially empty list, sorted tuples, and then the index, sort by, and that function, which we have discussed just on the slide before this, will insert into sorted tuples, maintaining the correct sort order. So if we end up inserting all of the tuples into sorted tuples, by the end of our iteration of for loops, our sorted tuples list will be in the correct order that we needed. And then just, I guess another same thing as with the previous function, the order that we're sorting this in is going to be in increasing or non-decreasing order, if you're considering lists with duplicate elements at sort by. So does anyone have any questions for this? I'm going to keep this thing. So that is it for this question, and then Shreyas will continue.
Alright, so for this section, I'm going to be going over strings and loops. This should be mainly review for you guys, but I'm just going to go over one quick example from the past final. So on the right side, you would see the function. I'm just going to read it out, and if you have answers for the fill in the blank question, raise your hand, and we're just going to ask. So for this function, you would make a word. The input is one parameter, text, which is a type string. It returns a string. Now for this one, it would return text converted to lowercase, and with all leading and trailing non-alphanumeric characters removed. So one example here is if you pass Anya 1, 2, 3, it would convert everything to lowercase and return that back. Here, if you observe that there is no non-alphanumeric characters, nothing is removed. For the second example, we have $100.50 with question mark and exclamation marks and one extra space here. The output would be everything removed except the numbers. And for the last one, you have one alphabet and everything else being non-alphanumeric characters, so the output would just be. I hope you guys can see here. The output is supposed to be n, but there's a mistake on the slide. So I'll give you guys 1 or 2 minutes to go over the question. If you have an answer, raise your hand.
While I is less than the length of text, and text at position I is not in a string with all the special characters in it. Index in I have text equals the text at slice I colon. Index is assigned to like equals a text minus 1, and then you let's say and then this model you have while I is greater than 0, and then you have the same not in the special character state, and the text is equal to text at colon to I, and then you have return text dot strip dot lower.
That may be one of the versions of the answer. If you paid attention to the hint, you may use string methods. I'm pretty sure, I think Anya might have given you like a sheet at the back of the exam that has like functions and methods that you can use to make your life easier. Like you said, you use a string of non-alphanumeric characters. That is one way of going about. You can also use the string method is alpha num to check whether it's an alpha or a numeric character.
Yeah, isn't there one? Oh no, you were explaining.
So his answer may be correct. Oh, you have a question?
Yeah, would you do like for index is 0 and first index is more than the length of the string on this line? And as well like what's it called, that character in the text and the text bracket at this line. But once if it's like not alphabet numeric, right? Yeah. So if that condition is met, then we stop the loop, and then this text should be from that index to like the end, right? And then I think for the second one, we do the same thing, except instead of being on the first occurrence of like the alphanumeric things, it's like the second one is you're kind of going backwards to find the index of that alphanumeric, and then it's just like everything between two conditions.
Yes, that's exactly correct. So if you, for these types of questions, I would suggest look at the code once. You would have a rough understanding of what they expect you to do. As your friend told, for the first while loop, you see that you're increasing the index +1 every time. So, and whenever you read the docstring, if you observe that they don't care about any like non-alphanumeric characters within the string. So as long as you hit a single character, like an alphabet or a number, you should stop the loop because it's the first part of the thing that you do not want. It's only the leading and the trailing ones that you're supposed to get rid of, nothing in between. So for the first one, so here's the answer. Strings are just like arrays in Python. It's not exactly the same, but you iterate over them the same way. So here you have index equals 0 from the start. So for the while loop condition, you would have index is less than the length of text because you want to take care of the first part, and you want to only increase the index by 1 if it's not an alphabet or a number. So which is basically and not text, which is the character in the string, is al num. It returns true or false based on whether it's an alphanumeric character or not. And you just increase it. For this part, you would say text equals text index to the end of the string because you're only worried about the first part of the string. And you would just copy paste the entire string over to your new text variable. So as for the second while loop, you would keep your index to the end of the string. Remember, your string index starts from 0 to the length of the string minus 1 to be valid. So in your while loop condition, you would have indexes greater than or equal to 0 because you're going backwards now. And you do the same thing, text at index is al num or num. And based on that, if it's not an alphanumeric character, you decrease the index by 1. And after this, at the end, you would just say text equals, you could either put empty or like 0, whatever, index plus 1, because for string slicing, remember that it's inclusive of the first number that you put and exclusive of the second. So if you have a string like Anya 1, 2, 3, this is of length, let's see, 7. So if I do 0, 2, 3, then I would go 0, 1, 2, 3, but I would only get the string A and Y, and not A. A is excluded from this. Is that clear? Okay. And for the final return statement, you just convert it to lowercase, because that's what the function description is saying you to do, so that's pretty much it. Does anyone have any questions about this? Yes. So it's basically like, let me just give you an example. So if you have Anya 1, 2, 3, this one is index 0, this one is index 1, 2, 3, 4, 5, 6, right? So let's say you had some extra characters here, like this. You would remove these, right? So now you have, in your new text variable, you would have like, from here to here. Suppose there's like extra characters here as well that you don't want. This would be 5, 6, 7, 8. So you would start from here. This would be, when you do length of the string, you would get 9 as your thing, like the overall, for this one, yeah, this would be 9. So you'd be outside. So if you do like x9, this is an invalid position on the string because there's nothing over here. You're outside. So that's why you would do 1 minus, so you're at this point. And then you would just go back until you reach a numeric character. Is that clear? So, for the next topic, I'm going to be going over files. For this one, I'm just going to talk about some file operations in Python. So the basic one is just going to be open. It takes 2 parameters. File name, it's a string format, and mode, which is optional. The name of the file name and mode, it can be. So for the mode, there are 3 types of modes in Python. Read, append, and write. For read is by default. So if you don't put any mode, it's by default you're in read mode for the file. So you cannot write anything into the file or append anything to the file. So when you do open something in read mode, it opens the files for read, just as the name suggests. For A, if you pass in A as your mode with the file name, it's for appending. It opens a file and you can append data. It also creates a file if it does not exist in your system. And for W, which is for write, just as the name suggests, it opens a file and it allows you to write anything into the text file. And it also creates a file if it does not exist in your system. Note that the write mode overrides anything with overwrites the existing data in the file. So let's say you have a text file that has some important data, and you accidentally open it in write mode and you write like 1 character. Everything within the file is erased. It's gone forever. So just be careful when you're messing around with write mode. Yes?
So what would happen if you wanted to say, write something in the middle of the file? Would you use the append in that case?
Well, in that case, there would be, how do I explain it in AOA terms? Because for this one, you would be going over it in BO9 with pointers and cursors within the file. For now, okay. Yes, but in AO8, you don't have to worry about it. You don't have to worry about going in the middle of the file and adding something there. That's out of the scope of this course. You're going to be worrying about that in second year. So don't worry about that. So one example here is file. File is my variable. It's not an actual file, it's just a variable that I created. And I make it equal to open. Let's say there's file review.txt on my system. I do file review.txt in string, and I created an append. So anything I add just appends it to the end of the file. It does not overwrite it. And here are some file methods. So the first one is file.read. File is my variable. It is a method for reading from a file. By default, it returns the entire content of the file. So the next one, which you guys are going to be mainly using, is file.readLine. Just as the name suggests, it's a method for reading 1 line from the file. By combining your knowledge of loops, you can read line by line from a file using this method. And for writing into files, you have file.write. It is a method for writing into a file, just as the name suggests. For example, if I do file.write, good luck for the final exam, it writes a line into the file review.txt file, and when you open it, you would see that line in the first line. Or whatever, at the end of the line, if there's something else. And for the last one, file.close, it is a method to close the file, just as the name suggests, simple as that. And one good note to here is, it's good to close your file after you're finished working on it, just for good practices. And you will also learn the reason. Okay, so let's go over an example. This is question 4 from your final exam from last year. It's files and string splicing. So I'm just going to read over the question, and if you have the answer, just read it. So suppose we have to process files where data is stored in the following format. So you have the last name, first name, utor ID, student number, with no spaces in between. Here's an example of the contents of such file. You have Pavlovich, Anya Y, Pavlovich, and her student number, Gauda, Purva, Gauda Pur, and 1, 2, 3, 4, her student number. So your task is to store the data from this file in a dictionary that maps IDs which you will assign sequentially starting from 1 to a list in the format of UTOR-ID, student number, last name, first name. The data from the above file will thus be stored as follows. Here's an example. This is a dictionary. 1, the student ID, and then from here you have the array that contains UTOR-ID, student number, last name, and first name. And similarly for the second person. Now we would implement the following function according to the doctrine. So basically this function is getStudents has one parameter, data file, which is a text.io, and it returns a dictionary of integer mapped to a list of strings. It returns a dictionary that maps the student ID to the list, this list. Student IDs are assigned sequentially starting from 1. Precondition. The data file is already open, so you don't have to open it again. It's already done for you. And the values in the dictionary or of the format, or the file is in the format of last name, first name, UTOR-ID, and student name. Does anyone have a quick idea? Okay.
You start by making the dictionary, you do the empty dictionary, then you have the for loop that iterates every line in the file, and then you have like 4-line data file, and then you would have the list is equal to, the student list is equal to line dot split on the columns, and then you would have dictionary at position 1 is equal to a list of like line at position at of list line at position blah blah, and then just return dictionary.
Maybe one, but it's not the answer that I'm looking for. It may be an answer. I'm not sure. Yes.
So I'm thinking like, I think it's good you have to create the dictionary first, then I think like maybe we should like read the entire process using readline, like these read methods, like put into like a list, right? So then each line is gonna be in a list, right? Then we can get rid of the newline character at the end of each element in the list, and then like I think you use the dot split to like turn each like you know how copy all which and etc. right? All separate by commas. So then turn that into a list in and of itself. And do that for each item in that list. So then you can put this inside the list. And afterwards you can just select the indices. And then you put that one more to your dictionary. And your case would just be like the value I in your for loop. So for instance, oh no, I plus 1, I guess I plus 1 because we can't have 0. Yeah, that's what I'm thinking of. And then you would have that, yeah.
That may be one of the answers. It looks convincing to me, but the solution has a much simpler form. So let's just take a look at the solution. Oh yes. Oh wait. Okay, I'll go to you first, and then I'll go.
So I wrote like a rough draft. So I would like define ID equal to 1, and then result is an empty dictionary, and then I would read lines equals data file dot read line, so it would go through each line, and then I would start a for loop like for line in lines. Data is equal to, I would strip the lines to get rid of the /n character, and then split with a comma. I split the comma so that you can like index the data. And then result was an empty dictionary, so I would put result with the ID initial value of 1 equals to a list of, and then you could like see from the example, so then you could put data at index 2, comma data at index 3, comma data at index 0, comma data at index 1. And then you would, after that, inside the loop, you would put ID equals ID plus 1, so that in the next iteration, you would have the next ID. And then you would put also lines equal data file dot read line inside of that for loop, so that in the next iteration you would go through the next line. And then once everything is done, you would return the result.
Yes, that also works. Is there another solution? Yes.
I don't know this is the exact same solution that I just said, but what I would do is obviously you can create a dictionary, right? Then you have your for loop that goes that reads the line of each of the file each of the file lines. You would first strip that line, right? Just to get rid of that /n, split it with comma, and much like the previous solution, you would then essentially you have a list created from that split, right? And then and outside of the loop, I would create a variable for the ID, starting at 1, obviously. And what I would do is, for the dictionary, whatever its name is, I would have the at index the ID, right? It would equal to another list with the after you appended in the order that you appended the data in the order you want it to, right? From this split that you got. And then obviously increase the ID size, make up this iteration.
That is similar to what all three of you said in different formats. Did anyone have their hand raised at the back? Yes.
Just basically similar thing with it.
Same answer.
Just do a dictionary and then student ID will equal to 1 and then you just increment like that. Like if you use lines, line not split and then continue doing it. And that's
So everybody's had the answer. That's great. That's good to see. Yes.
Yeah, so firstly I would set up a dictionary, then I would set up a while loop that would basically go on indefinitely until we reach the end of the file. To check that, inside of the while loop, I would have some variable line which would be equal to the data file dot read line. So I would read the line and then I would immediately check if the line is not empty. If it's empty, I would just break out of the while loop because we have reached the end of the file. But however, if the line that you just read is not empty, I would split it into, once again, by the comma. And then what I noticed is that the output basically is equivalent to the input, but the last name, the first name is like one group, and the user ID and student number is a second group, and they're just swapped places. So what I would do is I would basically, once again, I forgot you need to keep track of the IDs, so we would have a variable incrementing by 1, and then every time we basically have a dictionary, have the ID equal to these two categories just swapped around using the splice operator.
That's a good point to notice that you can the output in the dictionary is similar to the contents of the file, just like the two elements swap. So you can use list splicing to make it more efficient rather than holding individual data separately in each variable. I think you had a question. What do you mean by swap? Yeah, it's similar to, okay, I'll go over the solution. If you still don't understand, I'll answer. Okay. So for the solution, we have this. So as first, before I go over the solutions, it's better to have variables names that are meaningful. So the TA or whoever is marking it understands what the variable is for. And sometimes you may also leave marks if you don't put it. So for this one, we have student ID equals 1. We created an empty dictionary, student ID to data. Literally says what we're doing here. So we use a for loop for line in data file. The data file is already open for reading. And as suggested in the previous slide, I told that you can use your ID as a for loop to read lines from the file one by one. So when you do for line in data file, you read the first line from the file. Now, in order to clean up the data of the line, you do line.strip. Gets rid of every leading white spaces. So it just gets rid of that and the new line character. And then you split it by the comma, which creates an array. And student data is now an array that consists of the user ID, student number, last name, and first name, in some order. Now, with the student data, you would splice it. As he said, we take the first two elements, the last two elements, and keep it at the first. So you do 2 to the end of the list, which is basically the last two elements, plus the student data from the first to the last. It's basically like if I have a list of, I don't know, 1, 2, 3, 4. If I do, and this is equal to 8, if I do B is equal to A from, okay, so this is 0, 1, 2, 3, these are the indices. And then if you do A to 2 to the end, this is basically the end of the file. So you take these two, and then you add it with A from the starting of the file, starting of the array to 2. You get these two. When you add them together, you get a list that's basically 3, 4, 1, 2. Right? So once you have that, you just store it back into student data. That's exactly the format that you want it in your dictionary too. So now, you basically map your array with your ID. So in the dictionary, you say student ID to data with the key, which is the student ID, is equal to student data, which is basically the new array that you create. You make it equal, you create an element in your dictionary, and then you increase the ID plus 1, and you let the for loop do its job. It's going to do the same thing again and again for each and every line after that. Is that clear? Yes? No, the for loop takes care of that. Because the way the for loop is structured here is for a line in data file, it reads the first line, it does its job, increases the ID by 1, and in the next iteration it's going to be having technically a pointer at the end, it's going to read the next one, it does the same job like it reaches, and it does it. And at the end you just return the dictionary. All good? Yes.
Yeah, just a quick question. So, what's the purpose of the script one? I understand split is like for separating separating into a list, but what's the purpose for the script?
Good question. For those of you who do not know the method strip is basically like in a text file you have, let's say you have 3 lines. At the end of each line you have like an invisible new line character because you're going to the next line. And when you split it, technically the /n new line character is also with the last word of the line. And you want to get rid of all those white spaces, any like garbage at the start and the end of the line. So you like when you do some string dot strip, it gets rid of all the white spaces before and after the strip.
So what would happen if you just forgot to put that like script?
Well, in this one, if you forgot to put that, I probably think you would lose like 0.5 or 1 because you're not, like if you have a name, Anya/n, that's not really a name. Like Professor Anya's name is just A-N-Y-A, not /n, right? So you want to keep the data clean, and it's also to make sure that you don't have any unnecessary. Yes?
Would it be faster to just index up till the last index, or does it not matter? At least that's
For the slicing?
for the strip. And instead of line dot strip, just go up to -1.
I don't think that would work because /n is also a character, right? What if you also accidentally grab that into your word if you do negative?
I don't understand. If we index from 0 to -1,
Right.
just ignore the slash.
I'm not sure if Python takes this.
For the case where you miss the last index and not do strip, you might miss cases where they do new paragraphs, which have 2 /n characters instead of 1. So.
That would also be the strip is the safest way to go because it takes care of all the backend stuff, all the other cases. So that's and splitting is just basically splits the $, a unique name, but it's still a name of a person, so we respect that and put it into the file. Okay. Let's go into multiple choice. Oh yes.
How would we know that you can't just append it to a new list and create
You mean like if you already have a list and you want to append new values to the list?
Yeah, like this one, the values would basically a list, right?
Right.
So what if we just appended the value like for each parameter into the
B? Oh, B, okay, B. Okay, yes. B, okay. Is there anyone? B, okay. Anyone else? Yes. Okay, there's majority goes for B. Let's see what the correct answer is. It is B. So the reason is, let me just draw a memory model to make it more intuitive for people who look at it. So we have an array. So, right? This is our first line of the code. When we do a memory model for this one, we have, let's say, 8 in ID 1. this maps to something of an array 1, 2, 3, somewhere in the memory, right? When I do the second line, b equals a new variable is created. So let's call it id2. Call it b. This is equal to a. In Python, it doesn't create a new array of the same thing. Instead, since b is equal to a, b also points to the same array. Is that clear? Similarly, for c, it creates a new variable, c. C is pointing to b, but b is pointing to a. So c is again pointing to the same thing. So there's not 3 lists here, there's only one list, and all 3 of the variables are pointing to the same list. So that's why there's only one object. Or, yes, there's only one list object in the memory after the whole execution will go. Is that clear? Okay, next question. What is the result output of running the Python file with the following contents? So we have a function that takes an input as L, has a list, it takes an input of list of integers and returns nothing. This is what this means. Inside the function we have L equals 10, 11, 12, and outside the function we have L equals 1, 2, 3, we pass in that array and we print the array. What do you think the answer is? Yes. I'll come to you next. Yes. B? Okay. B? Okay. B? Okay. B. Okay. B. Okay, everybody's going B. Okay. The correct answer is B, of course. I think you might have seen this in the midterm. I went over this. It's a rough overview for this question is basically you create an array 1, 2, 3. You pass in that array to the function, right? Inside the function scope, L is not the same as the variable. Okay, maybe I'll just try it. This is much easier. Okay, so we have L equals 1, 2, 3. And we pass this into the function. Let's call this F. I'll call this L. So when we pass the same array, L equals 1, 2, 3 inside the function, we have L star equaling this, right? This variable is not the same as L. And inside the function, L is being manipulated to point to a new array of 10, 11, 12, right? And you observe that the function does not return anything. So whatever happens in this section, in this function scope, gets deleted after the function has completed execution. So once you come out of the function, you're at FL, and you print the array. The array is still pointing to 1, 2, 3. So when you print it, it's going to be 1, 2, 3, and not 10, 11, 12. Is that clear?
Does that happen only because it returns something?
Well, no, even if it was returning, well, if it was returning a list, let's say it was returning a list here, of list of integers. Even if you return something here, it's supposed to be, F holds some return value, but it's not being stored outside. So it's not like, I don't know, ARR, right? If the function returns something, then output would be stored by array, and then if you print array, that would be 10 and 11, 12. Since it's not being stored, it just like disappears. It's not here. You don't have access to that URL. Is that clear? Yes?
What if it said print FL?
Print FL? It would still return nothing. Since it's not returning anything, it doesn't matter. But if it was returning, then it would, I think, print URL. Right? Okay. Any questions? No? Okay. Next question. Same business. What is the result of running the Python file with the following contents? Here you have a equals 1, 2, 3. A at third index is equal to 4. Now print the array. What is the output? Yes. Error. Okay. Okay. Error. Anyone else? Yes. Error. Okay. Got it. Same. Okay. Anyone else? Okay. Everybody said. As you observe, 0, 1, 2, 1, 2, It's the length of the list, so when you access the length of the list, so when you access the third index, it's not even in there. Right? What is the result of running a Python file with the following contents again? Now, A is equal to a two-dimensional array. The first element is an array which contains 1, 2, 3. The second element of A is another array of length 2, contains 4, 5, and the third element is a 1D array that contains only one element, 6. B is equal to A0. A0 is 1, 2, 3. A0 dot append is 200, or you're appending 200 into that thing, and you're printing B. What is the following out? Yes. 8. 8? Okay. Yes.
A.
A.
Wait, okay. Yes.
I would say B.
B. Okay. Yes. B. B. Okay. Anyone else? Got the last two answers is B. Everything else is A. Yes. B. Okay. Let's see the answer. It's A. So let's see. Let's draw a memory model. And then we have A0 is equal to 1, 2, 3. So here, this is the key point. A0, when the line A0 runs, we're creating a new instance of the thing. So we have when you do A0 is equal to 1, 2, 3, there's a new ID in the memory model that's pointing to 1, 2, 3. This is not the same as just, right? And when you do append 200, you are affecting only this new one that you created, but you're printing B, which is still pointing to the original 1, 2, 3 arrays. Is that clear? Yes?
Is the original list A, is that she?
Yes, great. Right. So coming back to the question, so if you do the original one, this one. In this one, since B is pointing to the original one, and in your third line you say A0 is equal to 1, 2, 3, you're basically creating a new instance of the array that's pointing towards this index, which is basically new. And then you do A0 dot append 1. So this is what happens, but B is still pointing to the original one. B is not affected.
What if the third line wasn't?
If the third line was not included, then B would contain. That's the important part. The third line is what affects the output of the array B. Is that clear?
I said that if the third line wasn't included, then what would happen? And you said that it would happen. Because it would just point to the list. Then we would include it.
Yes. Yeah. It's like in a more detail. So we know this is index 0. A0 is pointing to a new list, 1, 2. And then in the third line, when you do A0 is equal to 1, 2, 3, it basically has a new list being created. this one is gone. A0 points to this one. But before the third line's execution, we know we did B is equal to A0. A0 was initially 1, 2, 3, right? So when you print B, you still print the original one. It's not gone. B still holds the information. But because of the third line, A0 is equal to 1, 2, 3, you have A0 pointing to a new array containing the same elements. And once you do A0 dot append 200, this is being affected. So you add 200 here. So B is still pointing to this one. Right? That's why you print at the end 1, 2, 3. Yes.
So if the third line wasn't there, the answer would be B.
Is that clear for everyone? Next question. Same thing. Result, running the Python file, what are the contents? You have an array A, 1, 2, 3, 4, 5, for item in A, item equal to item times 2, print A. Yes.
It would be C.
C, okay. Yes. A. Okay. Yes. A. A. Okay. A. Okay. Anyone else? In the back? Yes. A. Okay. Everybody's going with A. The correct answer is A. Why is that? Okay. So here we observe that we have an array 1, 2, 3, 4, 5. Then we do for item in A. So item basically carries or is equal to the values of each element in A. So in the first iteration, item is going to be equal to 1. In the for loop, you say item equals item times 2. So item becomes 2. But you're not storing that back into the array itself. The only way you can store something back in the array is if you're accessing the array at that particular index. Here you're only taking the values from the array itself. So, for the memory model, you have A is equal to 1, 2, 5. The first time, item is going to be pointing to 1. And then you multiply by 2. This is going to be 2, right? But the elements inside the array is not being affected.
Sorry, to anyone who got a chocolate, there's nuts in there, so if you're allergic, please don't eat it. We forgot to tell you guys up front.
Okay, coming back to the topic. So, when item has 1 and you multiply by 2, item is now having a value of 2. Now, since you're not doing A0 or AI, or actually, you're not indexing basically. You're only accessing the elements of the array 1 by 1 and you're multiplying them, but you're not storing them in the array. That's why when you print at the end for 5, that
If you wanted to get answer C, you would for loop at index item at index item. Never you would have to store keep track. So in A index what equal.
So if you modify, the quick solution would be the I in you basically do A is equal to AI access to the chain, store back. This would affect the list itself. Because you're accessing the array, the element, multiplying it by 2, and you're stacking to the array itself.
It's a counter outside or
Yes. That's basically a while loop, right? You may create a variable I or whatever it is. I equals 0 and multiplies for it back, the array is changed. In this, it's only accessing the elements inside, modifying it, but forgetting to change it or store it. Okay, next question. Same thing. What is the result? The function takes the input of integers, returns nothing. For item in L, same array. A is the same array when it returns A. What is the A? What is the output? Yes. 8. Okay. Okay. 8. Okay. 8. Okay. Yes. Okay. Okay. Everyone else with a different answer. Oh. Okay. Oh. Okay. It's the same thing here. It's forgetting to store the changed value inside the array. So even if you pass it into the function, it's doing the same thing. You're not modifying the elements inside the array. You're modifying it outside, but you're not storing it back, so you're not getting it. In this case, if this was inside the function, and you modify the elements, but you return nothing, and outside the function you put A, the return value would be 2, 4, 6, 8, 10. Is that clear? If the question was different. Right? Yes, because in this case, even though you're not returning anything, you're modifying the original array. So the elements inside would be changed, and you would print that. Right? Any questions? No? Tuples. Wait, I think we should go for a break. 10 minutes break. Everybody looks happy. Okay. For those of you who haven't gotten chocolate after answering some of the questions,
We're good.
Alright guys, we'll get started again. So this part, can you guys hear me at the back? Okay. So this part I don't think should take too long. I assume by this time of the course, you guys will have already a good understanding of tuples and dictionaries. But we'll do a quick review in case some people are not. So a tuple, in this case an tuple is an order grouping of n elements. It's similar to a list. It's kind of like a collection. Unlike lists, tuples are immutable. So I assume that you guys know that lists were immutable. Essentially, you can change the elements in it. Essentially, assign different item assignments. So do you guys understand what mutability means? You got it? Right. So what do you guys think would happen if I tried to perform an item assignment on a tuple?
Error.
Error, yeah. So you gotta type error. Yeah, so what if we're considering the elements inside of a tuple, say we have a list.
Just louder.
Okay.
Yeah.
So if we're considering like elements inside of a tuple, though for example if we have a list inside of a tuple, that can be mutable in that case. However, if you have a tuple inside of a list and you try to modify your tuple, obviously that follows the same thing where it's also immutable. Do you guys need an example for this or no? You guys got it? Okay, so this one will just be, this one is showing you how they access tuples. Essentially, it's very similar to lists. Only difference again is the mutability part. If you consider the length of a tuple, for example, a tuple with n elements in it, then obviously its length will be n. And then if you're trying to index a tuple, you can do that. So you just similarly to a list, you just index it by its index reference. And yeah, so similarly again, you can do slicing. I don't think there's too much to it. So we can move on to dictionaries. So dictionaries are unordered collections of key-value pairs. So we can't get the first or last element in a dictionary due to it being obviously by referencing by key-value pairs. The values can be any type. You can also include another dictionary. However, our keys in our dictionary must be immutable data types, ones that can be changed or modified. Can someone give me an example of a dictionary? Any dictionary, yeah.
So
obviously you have the curly brackets, one as say the key, or you could have like the word one as the key, and then one colon, and then number one, comma, and then you would kind of just repeat that for say 2, 3,
Right. So if I have a dictionary where I have, for example, curly brackets, and then I have a list as a key, do you think that's possible? No? Yeah, you'd be right there. Because your key, again mentioned here, it must be immutable. Yeah.
What does it mean by unordered collection?
Yeah, so essentially, it doesn't go by any order. So like for example, in an array, it'd all be ordered, right? However, this one you can reference anything. So like you're just referencing by keys. Essentially, another term that people use for dictionaries is called a hash map. Essentially, it calls by hashing references. You'll learn more about this in second year. Because yeah, the hash is a hash function, stuff like that. It essentially is like a string, a very distinct string referencing your values or keys, and that's how you assign types of things. Essentially, you can just reference anything in the collection, and there is no particular order to it. So it's it's unordered. So again, so here are some valid keys. So ints, flows, strings, tuples, these are all immutable, so they're valid. Obviously, you can't have, like we mentioned earlier, a list. You can't have another dictionary as a key. So yeah. So some of the operators, functions we have in here. So we have the in operator. You probably have seen the in operator when using for loops, because you'll have, for example, like for, it's like a for each loop, and that's what it's formally called. But so for example, for element in a list, that's where you use the in. It's very straightforward, very high level, like English straight away, you understand what's happening. So in this case, we have like a dictionary where it contains the fruits and also the costs as the values. So you just mention by the key, so if you want to call it. So if you have a key in our dictionary, then that one will output true. So obviously these give you a boolean output. The len function operates very similarly to like almost anything in Python. You're just getting the length of it. It's referencing the length of the keys. So how many keys there are will be how many length. What will be what's the length. In terms of items, this one's a little bit less, more or less seen, but essentially all it does, it returns a collection of your tuples, where each tuple represents the first. So your index 0 of your tuple will be your key, and then after that will be your value. Do you guys want to go over an example for the use case of items, or no? Yeah? So say we have a dictionary, let's just call it x equals to a, 1, comma, b, and let's do c. So a very simple one you could do would be just consider a conditional. Let's think of, let's just do a very simple one. So let's see if b2 is in, and we're using an in operator here, in x. What do you guys, okay, fine, I'll just do a return statement here. And then false will do false. I'll second. What do you guys think would be the output here? Yeah? False. False? Yes. What about false? False? So in this case, this would be true because we have B2. Oh, sorry. I missed one part. Okay. That would be right. You guys would be right since it's false. Okay, what about here? True. Okay, yeah. So like this is very simple. Typically you don't really, at least I don't often use this too much, but that's a couple, yeah. So you're just calling a couple, like, because you know that those items will be tuples, right? It outputs. So yeah, you're just referencing it like that. All right, so some more methods here. These actually you will use. You could use quite a bit in terms of dictionaries, due to dictionaries being very popular and very good for complexity wise. So first case we have here is dot values. So in this case they have again the same dictionary. They're just referencing for each value in fruits to cost dot values. And essentially all it is, again by this name, very high level, is just it's outputting all its values in its dictionary. Same thing goes for keys, it's just outputting our keys, or it's referencing our keys, and in this case they're printing out the keys. And then, okay, this one is, yes? So the values and keys, they'll just be what the values, like the value is. It won't be a couple of including the key and the value, like items is, because items will be your general thing.
So like if you call through the and printed that, what would you get?
So that one will, sorry.
If you just like print fruit costs dot keys, what would that give you? So like
Apple, banana.
So like a list or
No, it's like a dictionary. So if you print it just like that, in the output you'll get dict, and then in brackets, and then you'll have like, it's like, then you'll have it in a list, and then inside of it will be strings. But it's just essentially referencing all of the keys in there, right? So it'll be, those keys are strings in this case, so you'll have that inside of what is output. Normally you don't want to just print out like the whole thing like that, because you'll just get something absurd in your console. But yeah, so you just, because that one you're using to reference the, so that one you're going to use to reference the keys in it. So if you, like, if you, let me see where exactly it is. Yeah, so if you actually call that, you'll get like it will say in your terminal, it will say dict, and then you'll have like a list. So it's just representing that you'll have all of these keys in it, right? Because you're just calling all the general keys. Yeah.
If you're calling the dot keys method from this particular example,
Yeah.
because the keys are strings, are you gonna get like string and then absolute inside the string, or will you just get absolute?
No, when you output, it just gives you, it's a string still, right? But when you output in your console, it'll just print it out as that.
For the key, just to summarize, just if you use the keys, it'll just output what the key is, including what type it is. So it would, for in this case, when you use keys, you will just output the string apple.
Right.
And then absolutes and then banana.
Yeah, so another example for that would be if your key, if we were to say instead of apple, it would just be like the integer 1, then we'll just output 1. Right? We have also assignment operators. So, and this is quite important. You will most likely definitely use this in your final or any of your exams. So it's pretty straightforward. It acts very similar to a list in terms of indexing, but in this case, you're referencing by key. So you will mention, so the like the syntax will just be your dictionary name, and then in brackets, in square brackets, it will be your key you're trying to reference to. However, if your key does not actually exist in the current dictionary, then you're actually adding a new key along with a new value in. If it does exist, if it did exist previously in your dictionary, then you're just replacing your previous value with the new value if we're using the equals operator here. Yeah. Any questions on that? No? Okay. Alright, so now let's move on to generating test cases. So the whole overview of it is like you're trying to figure out what you're testing. When you're testing, you want to know with your function if it's returning something or if it's not. If you see where it's returning none, then it's implying some kind of mutation. Elsewise, you want to mention, like what you're trying to return. So, and then what makes a good set of test cases? Test only with, so you only want to test with valid inputs, like that are specified in the description. So that will be like, you'll have to consider for the preconditions. So you want to consider edge cases, normal cases. You guys probably went through this in class. Something important to note is that for collection types, so example for lists or tuples, for the test cases, you want to make sure that you have at least 0, 1, and many. So what that means is you want to test, for example, for a list, it would be an empty list. If it was, and then if you're considering for 1, it's got to be, for example, 1 element in the list. Many would be many elements, obviously. If there's other restrictions on what could happen in the list, then you would obviously do potentially many, no, sorry, not many, but several of each of those kinds. So you could have several kinds of ones test and also several of many. We'll see an example later for that. So here's an example. This was on a past final. Essentially here you have a definition of a function called getNum of mint. And essentially the description tells you that to return the number of smallest elements of a list. Your input parameters is just a list of ints, and you're trying to return a int. So you guys can have a few minutes or a few seconds to look over it and just try to consider some of them. Yep. Empty list, sure. Anyone else? Yep.
All the integers are the exact same value.
All the integers are the exact same value. So
you have like
how many?
ones.
All ones. Okay. Yeah.
A list with only one element in it.
Sure. Yep.
You can have a list with many elements in it, but only one, like minimum number.
One minimum number. And then anyone else? Yeah.
Like a couple of minimum numbers, a couple of different ones.
Yeah. So what category would that fall?
There would be many elements and
Yeah, many. Right.
yeah.
So you got it. Yeah, I think you guys covered everything there. So that was like, yeah. Okay, but that would essentially fall in the same one there because you're considering for many minimums there, right? Good show. Because they didn't give you an explicit precondition where it has to be positive, so it's good to consider those. Yeah, so here are some example solutions. You guys mentioned all, that's good. Oh yeah. Yeah, so if it's empty, essentially, I don't think they gave you the code. Yeah, so there's no code there, but essentially in the code you'll have a initialization for a variable to check for every time you're iterating through if it's the smallest number or not. And that iteration will usually that initialization will start at 0. So essentially, if your list is empty, then you'll have obviously like no smallest element. Yeah. All right. The next one will be a replace function. Essentially, you're given x and y and a list, and you want to mutate it. Yeah. So I'll give you guys a few seconds to consider some test cases, and just raise your hand and just let them know. Like that one? Okay, sure.
What happens if there is no x in there? There is like no there is no value to replace.
What do you mean?
Like a string with nothing with x in it.
Yeah, like an empty string, for example, or you just have, say, you choose to try and replace something that isn't even in the string.
So you're saying that's a test case, or are you just asking? Okay, yeah, that would work. So essentially, you're saying, but like, which one would that fall under? What category would that fall under? Because you kind of set a more generalized version. Yeah.
What is the parameter of object?
Okay, in this case, it can be any because they didn't specify what list could be. So you can have it be integer, you know, it could be a string, it can be any of any type essentially because it's specified as an object. Because sorry. It could be because if you have the list inside of a list, right? If you can have another list inside. So if you're referencing a list, if X is a list and list contains a list inside of it, right? And if you want to replace it with Y, say Y is an int, then you can still replace that, right? So that's what object is just referring to. So any test cases up there?
I would say I would have the LST or the list have one element and the value of X is changed, and then have one element and the value of it is not changed. So there's like 2 test cases.
That's 2 test cases, right? And that would be fall under the 1 category, right?
Yeah.
Any more? Yeah.
I have a question. Can we have X and Y as
Sorry?
X and Y as
As none? No, you can't have them as none because they're defined as objects. So objects is it's like a general because we're dealing with lists, right? We're not dealing with arrays. Arrays can only have one type inside of them. So lists you can have any type inside of them, like many types. You can have ints, you can have a collection of ints, strings, and you can even have a list inside of the list, right? So it's just referencing and saying that it can be like of any type in there.
So none is not.
No, I don't believe it's a type, right?
I have a question.
Yeah. Like, you would, like, yeah. Someone else had a test case? Do you have one? No? Okay.
I have a question.
Yeah.
So let's say like X is an integer.
Yeah.
And then Y is also an integer. I'd say list is just like a list of lists. Right? Let's say there's 2 lists inside this, and each list is just all X's. So then with this function, like replace every X inside of that list with Y's. Are we saying that like are we saying that like each item inside the list is X? So like you can have a list inside a list with X's in them. Is that like possible? Or?
No, so in this case, well, if you define X to be an integer, you said?
Yeah, so like X is an integer, and then it says return returns of X with Y list. And technically, like if you have another list inside the big list, right? You have X inside the small list. I mean, technically it's inside that list, so like. Or is that like not just like.
So like, I guess like that would depend on like the kind of code that you're given. Obviously, you aren't given code here.
That's not like that.
Yeah.
I think for test cases, we have 3. One could be that there's no occurrence of X at all in this. One could be that there's one occurrence, and one could be that there's many occurrences, so it replaces many occurrences.
Sure. Okay. Yeah. Sure. But you're considering for many like those 3 general cases.
Yeah.
Okay.
Like 0, 1, many.
Yeah.
Occurrences.
Yeah. So that's a good baseline, but there could be more, right? There's more test cases that are more specific in terms of what you're given here. Any more ideas? Yeah. Sorry, can you repeat that? Yeah. And why? Okay. I'm looking for, okay, yeah, that could work, right? But I'm looking for more specific examples. Like, can you give me an example where I'm actually replacing something or I'm not replacing something?
Have a list of say 4 and X, which is the 1, 2, 1, 2, and Y. Then Y is another tuple that is deleting 3, and then replace X with Y.
So in your list, you only have one object. You only have your X object.
And then here, 2 tuples, that's X, 1, 2, 1, 2.
Yeah.
And then we have the string, say Y.
Okay.
And then
mention y is a string, but y here is just defined as an object, right?
Well, you just, the string is like A in the string, so.
Oh, okay, yeah, I see what you're saying. You just meant a general string. Okay, yeah. So like, these are all the examples. You guys mentioned a good amount of them. Someone mentioned both cases for the one case, and then for many cases, obviously we have when we have only one occurrence of x in the long list. We can have multiple cases of our x in our long list, in which we have to replace our y, and there could be the case where there's no x's at all. Of course, we can never forget about the empty list. That's always our zero case. Yeah. And then now we're moving on to the design recipe, function design recipe. I assume that you guys probably did this early on in your course, so it should be pretty straightforward with you guys. So I'm gonna just power through these. Here's an example. So this was on a past final, I believe, or past exam. In this question, you'll design and implement a function to get average by section. This function takes a dictionary and maps a student ID integer to a tuple of 2 elements, which is defined as a section that the student is registered in, and the student's grade. So essentially, you have a tuple where the first index, so index 0, will have your section, and second index will be your student's grade. And then the function returns a dictionary that maps a section string to the average of grades obtained by all students registered in that section. Average grades are rounded up to the nearest integer. And then, so in this first part, let's just look at the function header. Can someone tell me what our input parameters would be and their types? Yeah. Yep. And then, so here we have that. To be more specific, I guess you could mention inside that your dictionary keys will be integers, and then your values will be a tuple, right? That's always good to mention those. All right, and then, so now we're going to move on to the descriptions. This should be pretty straightforward as well. It's just some more English to read. So essentially the steps are you want to describe the return value. It's important to note that in your function header, if you're not returning anything and what it says after the arrow is none, then obviously you're not returning anything, so you don't have to, there's nothing to mention for return. All you have to do is you have to mention that you're what you're modifying in your function. So another thing that you have to mention in your description, other than the return or modifying part, is your input parameter names. So, in our here we have we follow with the same example. Can anyone give me a description of it? No? Should I just show the solution? Okay. Oh, I forgot to mention you also need your preconditions in your description, but that's usually given. You'll always see that in the function description where there will be preconditions. But yeah, here in this case, we're just returning a dictionary that maps section to a list of grades for that section using the information in our given dictionary ID to grade info. Also one thing to mention is that unlike what I just said, you don't have to mention the type of your input parameter in your description. Preconditions are pretty given. It's they mentioned it up there. Okay. So types of doc strings. I mentioned earlier that in our doc strings we can have a case where we're actually returning something and also a case where we're just, yes, a question up there?
Yeah, suppose precondition, why do you have to write that it maps an integer to a tuple, because doesn't the type of map talk about that already?
I mean, yeah, I suppose so. Yeah, I think in this case, actually, you probably won't even need that. Usually, because the preconditions you're considering, if you're considering for some kind of bounds, in terms of restrictions on your input, but this one doesn't exactly define that. I would say that the reason why this was on the solution was because they did explicitly mention it in the in your given description above, right? They explicitly mentioned that what the ID grade info actually maps to. So I guess it's kind of more of a repetition here, just to get it more clear. Something important to note about these descriptions are basically what Anya probably mentioned is that essentially if I am someone looking at your code, I shouldn't even have to read your code. Based off of this description, I should be able to already know what your function is about to do and what it's about to output or modify. Alright, so moving on to these tests. We have a type 1 test where we have no mutation, and we have a return value. So in this case, we have these, you have your triple arrow signs. Essentially this is mimicking a actual Python compiler console. Essentially you're just calling your function and you want to output something, right? Because you have a return statement, thus you want to output. How to check these is you actually run your own the function with your code based on that test case, and if you get the same number as what you wrote as you're supposed to get in your test case, then that's correct. If I'm looking at this without looking at your code and running your code, I should be able to understand that when I run this case, it should give me that number. So in this case, this is just a function called number of boxes. That's not too big of the highlight of this. The highlight of this is just the syntax or formatting of how you should be writing out these return value test cases. Is that clear? Yeah. You guys have probably done this quite a bit on assignments. The type 2 is just where, like I mentioned before, you don't have a return statement, so then it'll be just a none. So essentially you're just performing a mutation. So in this case, you want to define or initialize some kind of variable, and then you want to call your function with respect to that variable. And then in this case, they just print it out. When you just call the thing in the Python console, it will just print it out for you. So in this case, so you're just printing out what the function does to your defined. In this case, it'll be a list, but most times it'll be any kind of variable. And normally you want to check if the variable is expected. So, for example, you can have a case where you're modifying a list, right? So you know what you want that list to be in the end. So what you can do is you can equate them using the double equal sign, and if that produces a boolean such that it's true, or if it's true, it should stay true. If you're considering a case for false, and you have a list that does not equal to the actual list you want, then that would obviously be false. That's essentially what you're doing with these mutation type of functions that don't give you any return statements. Okay, so going back to that question, can anybody mention any of these, any test cases for this? Yeah. Do you guys still remember what the function is? I mean, I guess the function definition is there. Yeah?
So you have your dictionary, right? Let's just say it's the dictionary. The keys in this case are 1, 2, 3, and so on. So let's just say 1, 2, 3.
Okay.
And then your tuple, you have a course number, a section number. So for key 1, you're going to have a tuple that has section 1 and 98. Then you're going to have a key number 2, section 2, 48. And then you'll have key 3, you'll have section 1 again, right? The output would be another dictionary, right? And this time, what it's going to be is section 1, right, as your key. And then you're going to have a list with 98 and 58. And then your second key, which would be section 2, would be that would be your key, section 2, and then your value would be just a list with 48.
Yeah, so that'd be a good case of having like actual dictionary inputs or keys and values. And yeah, that's a good case where it would print out exactly what you want. You can also do like what I mentioned before, a double equal sign to equate it and check if it's true. So yeah, that works. Is there any other test cases? Yeah.
You could do a case where the input dictionary, like all the tuples, like the string is all one section. So basically, all the students are in the same section. And your output dictionary would only have like one key, which is that section, then the average.
Sure, yeah, that works too. That is kind of similar to his, because you're still doing exactly what the function is telling you to. You're mutating it. Yeah.
Just have an empty dictionary.
Yeah, that was what I was looking for. So you always want to remember you can have our empty cases, right? So here are the two cases we have here. Precisely what you mentioned, both of them. Okay, the next part is, I might have leaked it, but you guys, can someone give me a basic overview of what the actual code that you'll be writing looks like? The body part. Okay, I'll just go through it. So essentially, we want to initialize an empty dictionary called section to grades, and then we want to iterate over our values of our given dictionary. We can use our values method that we mentioned earlier, and then we want to create a variable called section, and we want that to be our info, and we defined previous constants to be section idx equals 0 and grade idx equals to 1. So those will be our constants, right? So we just reference those two because we're dealing with a tuple, and we just want to get our tuple values. And then if our section does not appear in our empty dictionary, then we want to create it as a key in there and assign a empty list. And then we would append our grade into that list, right? So if our section actually did appear in our, actually already previously appears in our section to grades defined dictionary, then we would skip that conditional, right? And then we just keep on appending grades to it. Pretty simple function here. Oh yeah, question?
Sorry, yeah, so, if you would go back to the actual, so you're saying that if it's not in section grades, of course you would want to create a key for it and then the value of the empty
Yeah.
list. But what happened? But in this case, if you have this section, right?
Yeah.
Wouldn't you also just immediately add the grade to that empty list?
Yeah. Yeah, that's like kind of what I mentioned there. So you're only creating a new key if that section doesn't appear. Even if it like does appear, you're always going to have appending the grade to that list or empty list.
Right.
Or just if it exists already in there, it won't be empty because that means there'll already be a grade in there. So you're just going to be appending a grade to it, right? Any other questions about the solution? No? Okay. Oh yeah.
I create my dictionary, and then in my protocol, it's like if this is not in it, you create a list, and then append it to that list. Else, you just append it to the list because it already exists.
What are you iterating over for your for loop?
I use grades.
so essentially you're appending the whole tuple to the. No, because like what if you, okay, so what you're doing is you'll end up with, I'm pretty sure based off what you said, you'll still end up with multiple sections that are like the same section, right?
Item index 0 of the item.
So you're only appending, okay, so you didn't define constants, is what you're saying?
Yeah.
Okay, so your code is the same but without constants. Okay, that's fine then. Typically in 808, Anya does stress about using constants though, because that is good practice. In your assignments, you would have seen the use of constants in a different file. I'm not entirely sure how she marks on final exams, but I would say always if you have a number, especially if that number won't be changing, set that as a constant. In this case, they actually give you those two constants, so I would actually use those rather than actually explicitly mention the index of 0 and 1. You know?
I don't use constants or I use marks.
If you're given constants, you could, right? Yeah. Alright. So this next function is using our previous function. So we want to get the average grades by our section. You guys can take a quick read of the function description and the test cases, and then let me know if you guys have any ideas for the code. Here's a hint, by the way. You can assume that these the math library is important. Okay. Does anyone have any? You want to go?
Yeah.
Okay.
So essentially, so we want to first create a variable, just for simplicity's sake, that kind of represents the solution you get from your helper function.
Right.
So let's just say you call that section to grade, right? So you get that. So you have initialize section to grade, right? Then you create a empty dictionary for what you're going to output eventually. So let's just say call that average.
Sure.
Right. And then what you would do is you would cycle through your section, right? Your section variable, and that would return all these. You would go to each of the values of section, right? And then you sum to collect all to get the total amount for each section in section variable, and then divide that by the length of the section of section 1 in this case. For example. And then obviously you wrap the whole thing with the ceiling. That way you get the if it's like a decimal, you can just round it up to the next highest, and then you take that variable and initialize it to the new dictionary with a section number as your key.
Yes.
And then just at the end of that loop, you just return.
Yeah. So that's basically completely correct. Essentially what our friend up front just exactly said is precisely what that solution is. Does everyone get what he meant by the solution? Or is there any questions?
So, I know that looking over a dictionary and changing it at the same time is bad. So, or it doesn't work at least. So, what if I make a different dictionary by looping the contents of the original dictionary into that dictionary?
That's what we're doing in this case. Right? We get our original dictionary from our helper function, right? And then we created a new dictionary called section to average. We're looping over our original one and appending and then creating new keys with our averages in our new dictionary. You have two for loops. me that afterwards. Okay, this one will just be based on tracing. So you're given the code right here, and can you produce some test cases for this? I'll just scroll through these. So what we can see here is from our function header first, we have two dictionaries that have keys that are ints, and both have lists of strings as our values. We see here that we have no return type, so no return statement. All we're doing here is mutating our dictionaries. Yeah, so if we're just looking at what our function does, before I explain it myself, does anyone have any idea what it actually does? I'm not going to show that answer. Yes?
So it looks at D2 and it looks at all the items in the list of D2, and if the item is not in the same in this dictionary at the position of K, then so if it looks at every item in D2 and it's not, and if an item as a key is not in D1 at that key, then add the item to that key.
As that item to that list for that key, right?
Yes.
Yeah, okay, yeah, you got it. Yeah, so essentially, if we're tracing it, we can start from the outer loop. We have for K in D2, so we're iterating through all of our lists in our dictionary for our given key. So that's that. And then for item in so our K will be our key, and then our item will be our list for our key. And then if the item isn't in our D1 for that given key, then we have to append our item to that to D1 for that given key. This is some just more explanation on exactly what it does. It's a pretty straightforward function. This would be an example of a test case for it. So we have D1 is a dictionary where we have key 1 and list that only contains X, as well as a key 3 where we have a list that contains Y and C. And then if we run this function and we have D1 and then our D2 is an empty dictionary, then we check if D1 is equal to the empty dictionary, and that would be true because we don't have anything there because there is nothing that's the same. Do you guys get that one? Or? All right, and then this will just be a few more test cases here. Oh yeah, also keep in mind of the precondition that every key from D2 is also in D1, but it's not necessarily the same the other way around. So in general, we will have all of these test cases. In this case, we're testing again properly with our followed format of 0, 1, and many. Does anyone have any questions about these test cases? It should be pretty straightforward with the function if you understand what the function is. It's good? Okay. If there's any more questions about this, you can just come to the front afterwards. But yeah, that's all I have to say. Yeah, so good luck on your guys' finals. Hope you guys all do well. Oh yeah, if you guys would be kindful enough, you guys can scan this QR code and we'll be in a quick feedback form